Good day, everyone. I hope you're having a good day. My name is Alfred. I'll be a tutor for today, and then we'll be learning about integration. Many are wondering what is integration, but we'll get to that on this video. You get to know what is integration. You get to know how to solve integration problems. You get to know how integration can be used in real life problems, right? Therefore, we will focus mainly on U-substitution and integration by parts. Many of the problems will be based on U-substitution and integration by parts. All right, let's get to it. Let's see, we have we have the definition, the explanation. I think based on this explanation, you'll get to know what is integration. All right, what is integration? Integration, we see that is a branch of calculus that deals with finding the area under curve. The area under curve. I will demonstrate this using a visual aid. All right. Accumulation. Let's continue. Accumulation of quantities and the reverse differentiation. Right. The reverse differentiation. In other words, is an antiderivative. Therefore, it is opposite of differentiation. We're gonna use, why are we saying it's a reverse process of differentiation? It's because we're gonna use the derived expression. We reverse it to its original form, right? That's why we call it antiderivative. How can we apply integration in real life problems? We can use it to calculate the displacement of a vehicle or any other moving object from velocity in physics, right? We can also use to calculate the total cost or revenue over time in economics. We can also use it to determine the population growth over an interval in biology. Lastly, we can use it to compute areas, volumes, and center mass in engineering. These are how we can use integration in real life problems. All right, let's get to the relationship. When it comes to relationship between integration and differentiation, we see that they are inverse processes. They are both inverse processes. In what manner? We see that while differentiation breaks things down into rates of change, integration pulls things together by accumulating change, right? This is the relationship. All right, let's move. Remember I said I'm gonna demonstrate using a visual aid of a area under a curve. All right, this is what I was going to use. Okay, sharp. We are given a graph of f of x is equal to x squared and an area under a curve from x is equal to 1 to x is equal to 3. Right? We see the highlighted space with the blue color here. This is where we're gonna find this area which is highlighted in blue, light blue, from what? From point 3 to point 1, right? How are we going to calculate? How are we going to calculate the area under curve? We're gonna use integration, right? We can use integration of f of x, which is equal to integration of from point 3 to 1. What is the equation? X to the power 2 dx. This is the equation, the expression that we're going to use to calculate the area under a curve, right? Let's look another example. Here we have a car. We have a velocity time graph where we integrate the velocity over time to calculate the distance, or we can say the displacement of this car. The displacement of this car, right? So we're gonna calculate from what time? From zero to 3, right? Therefore, what will be our expression to calculate this displacement? We're gonna use from 3. What is our upper value? Our upper value is 3 to 0. What is our equation? Will be velocity in terms of time dt. This is the expression that we're going to use to calculate what the distance, right? The distance or the displacement of this car. All right, let us move. Let's see what you have to achieve after this lesson. You need to understand what integration is, as I have explained it at the beginning of this video, and be able to recognize integration by parts. We're going to deal with integration by parts mostly, and then be able to use U-substitution to solve integration problems. Secondly, you have to recognize to be able to use U-substitution to solve integration problems, and you must be able to use what? Lipid. Why am I suggesting you to use lipid? Because I see it as a simpler method where you can master it and then be able to solve what? Integration by parts, right? We're gonna use what? Lipid. This is our method we're gonna use, right? All right, let us move. Here is the formula sheet. Please refer to the formula sheet to avoid making mistakes, right, when integrating. So when you're using the formula sheet, you will avoid making mistakes when integrating, right? So please refer to this formula sheet, as we're going to use it as well on this video. All right, now we're gonna practically solve what? Integration problems. Let's say example 1. Example 1. We have y is equal to, they say integrate, right? Integrate the following, right? The following, right? This is what I'm going to use. Therefore, let me wrap this one so that we cannot confuse things. All right, here we have y is equal to e to the exponent 1. Let me write this one. I'm gonna make a mistake. 1 over x squared all over x cubed. All right, let us further let us put this thing in a product manner, right? What do I mean in a product manner? We're gonna remove the division sign and convert it to a multiplication sign, right? So that how are we going to do that? You see that x cubed is under the division sign, therefore its exponent will be negative. Let us put it will be negative multiplication, as I've said. Therefore, I see an exponent of exponential there at the top, at the numerator. I'm gonna change it as well and make it make the exponent negative, right? We have changed our equation to a simplest manner where we can simply integrate it, right? What are we going to do? We're gonna integrate y in terms of x, say, okay, dx, right? This is what we're gonna do, right? Let us move. I think I'm running out of space. Let us rewrite what we have written there. We said integration of y in terms of dx, and then here we have x All right, we had this thing on our first slide. All right, how am I going to integrate this? Firstly, you need to determine what integration do you have. What type of integration do I have here? I can see that, let me try U-substitution. U-substitution is what comes first in my mind. U-substitution. Here we're going to use what? U-substitution. How are we going to use it? Remember, we're going to use this equation is equal to U. Is this plus constant. And remember, why are we using constant? Because remember, when we derive constant, it becomes 0, right? So we don't know if the constant was there or not there, but for in case, if it was there, we should put it. If it was not there, obviously it will be 0, right? So that's why we are always putting what? The constant. We are always putting what? This constant here, right? This C is constant. All right, let us see. Let us determine if this applies. Let us see if this applies to our integral expression, right? Let us see. Let us first let the exponent of exponential. Let us let the exponent of the exponential there to be u, right? Now u is equal to the exponent of the exponential, right? Therefore, let us derive u equation in terms of x. Let us see. It will be, we take the exponent to the front, and then we subtract 1 from the exponent, right? Therefore, let's cross multiply. I wanna be left with du here. It will be 3 here, and then dx, right? Remember, I want to substitute this, right? And then I have it when I derive the exponent. So let me make what? Let me divide by -2 to be left with this one alone on the other side, and with what? Dx. We're going to substitute dx, x cubed, negative cubed, and dx by du. All right, let us divide by -2. Therefore, we'll have, I made a mistake there, sorry. We'll have -half du is equal to x cubed dx. Oh, all right. I have what I have on the integral sign, right? On the integral expression. Let us move. I had something like we said we're gonna substitute. Oh, let me see. We said we are substituting what? The exponent by u. Therefore, we have something like this, right? Therefore, remember we had this du half du is equal to dx, right? And we see it here. Therefore, we're gonna substitute it by is identical, which is half du, right? Let us substitute it. Therefore, this will be, we substitute by half du, right? I'm gonna keep this here so that I didn't conscious anything. Alright, therefore, let's continue. We keep out what? When we arrive here, you see that we can derive u here because we have du, and then we can keep out what the constant, which is -1/2 e to the exponent du, right? Therefore, remember we had something like this. When we have du is equal to plus c, right? Therefore, when we derive this will be u plus c. Remember to put c, which is constant, right? Which is constant, right? And then remember, we're not integrating u, but we're integrating x. So let us put what we said at the beginning there. We said, remember, we said let u is equal to x to the exponent 2. Therefore, we're gonna substitute that. We said is half u. We're gonna substitute that u. Let me put it here. Let's substitute that u by is identical, as we said, is equal to x squared, x to the negative. I'm doing a mistake here. X to the negative 2 plus c. Therefore, the answer will be e to the exponent 1 over x squared over 2 plus c. Therefore, you have arrived to your answer. Therefore, this is our answer. Let us move to another problem. Problem number 2. Problem number 2. We have y is equal to cosec squared x, right? Cot x squared. Remember I said I like to remove I don't like the division sign, but I prefer the multiplication sign. So I'm gonna convert the division sign into multiplication. Therefore, the denominator will be, the exponent of the denominator will become negative. Let us put it. We'll have something like right. Remember, we are integrating this, right? What you are looking for, we are looking for okay. All right. We're looking for the integral of cosec squared x times then into brackets 1 minus cot x to the exponent 2, right? That is what we're looking for. All right. Let us solve this. All right. You need to what? To determine what type of integration do you have, right? All right. Here, we're focusing on the brackets. Always focus on the brackets first. Focus on the brackets. Therefore, we're gonna let what is inside the bracket. We're gonna let what it is inside the bracket to be u, right? Okay. As we have let what is inside the bracket equal to 1 minus cot x. Let us find, let us put it as we have said it is equal to squared times u squared dx. I forgot the dx there, forgive me. Dx, right? Right. Inside the bracket, u. All right. Let us find the derivative of du, right? Derivative of u in terms of x. We said will be like we said u is equal to 1 minus cot x, remember? Therefore, the differentiation of 1 will be 0. Therefore, we'll be left with negative. The differentiation of chord is equal to negative cosec squared x. Negative cosec x squared. Remember this. Refer to the formula sheet, right? Refer to the formula sheet. Refer to the formula sheet. All right. D or dx, when we differentiate cot x, will be negative cosec. Therefore, let's put it in bracket. Negative cosec is our squared, is our differentiation. Let's cross multiply and break brackets there. Let's first let me do this. Cosec squared dx, right? Negative times negative is positive. Okay, therefore we'll be left with cosec squared x dx, right? I see that cosec, I have cosec on my integral expression. On my integral expression, I have a cosec here. I have it, and I have also what, a dx. Therefore, I'm gonna substitute them by what? By their equivalent value. What is their equivalent value? The equivalent value is du. Therefore, I'm gonna say y dx is equal to, we said the inside bracket is u. We said cosec squared x dx. We're gonna what? Substitute this by its equivalent value, which is du here, right? Du. Okay, let us move. We say integral of dx is equal to integral of u to the exponent 2 du. Remember, we substituted what? Cosec squared dx by its equivalent value, which is du, right? Therefore, yeah. Let's move. Therefore, you know, when you have something like this, you're gonna add the exponent. You're gonna what? Let's refer to this. When you have something like, let me put a line here. Okay, when you have something like u du is equal to u plus 1 plus, let me wrap this one. Right, let me use, okay, it will be u 1 plus 1, the exponent plus 1, and then you divide by 8. Therefore, plus constant. Remember, constant is very important. Therefore, what is our answer? Our answer will be 2 divided by 2 plus c. You see, we're going to use this thing here. Therefore, how we're going to use it? We have what? This time we have exponent of negative 2. Therefore, we're going to say negative 2 plus 1 divided by negative 2 plus 1 plus c, right? Therefore, c is what? Is our constant. Therefore, we're going to say our answer will be negative 1 over negative 1 u negative to the exponent negative 1 over negative 1, right? Therefore, remember our u has its equivalent value. Let's see, we said our integral dx is equal to what? Is equal to u negative 1 over negative 1 plus c, right? Let us simplify further. We'll have something like yes, that negative is a fraction. When you have something like this, is equal to 1 over u. All right, therefore we have this, but we need to write the equivalent value of u. As you have said, u is equal to the bracket, inside bracket, which is 1 minus cot x. 1 minus cot x, where is it? Yes, here it is, right? We're gonna go and substitute it. U is what? Is 1. U is 1 1 minus cot x plus c. Therefore, this is our answer. Remember to always put a constant, right? This will be our answer. Let us move to another example. Right now we are moving to lipid. Actually, lipid. I want us to know lipid before we can solve these other expressions. What is lipid? L is for logarithm. And then E is for inverse. P is for polynomial. E is for exponential. And then T is for trigonometric function. Trigonometric function, right? Function. All right. Now we know lipid. Therefore, let's go and refer to it. Let's continue. Our expression is our equation is y is equal to exponential x times sine 3x. Okay. Therefore, we're gonna integrate. Therefore, we're gonna say integration of y dx is equal to integration of e dx. Okay. Integration of y dx. Okay, firstly you need to identify if this thing is what type of integration do you have here. So when you have a product of two terms carrying a variable which is x, a variable which is x, to integrate, know that the expression is the integration is by parts. We're gonna integrate this by parts, right? Integrate this by parts. So we're gonna use lipid. How can we use lipid? Through lipid, we're gonna choose which one do we have to integrate, which one do we have to differentiate, right? Here we're gonna have the derivative. Here we're gonna have integration, right? Which one are we going to derive? Which one are we going to integrate? The one that we're going to derive is the one that comes first on the lipid, right? And then the one that we're gonna integrate is the one that comes after the one that is going to be derived. All right, let's see. We have exponential there carrying x as an exponent, and we have a trigonometry carrying x inside with the coefficient of 3x. Therefore, trig comes last here. Trig comes last, and exponential comes before trig. Therefore, we're gonna derive the one that comes first. Therefore, the one that comes first is exponential. Remember the sign. Each row must have its own sign. The first one will be positive, the next one will be negative, the other one will be positive, as a pattern as we go down. Therefore, exponential, when we derive exponential, we derive it twice. We derive it twice, right? When we derive it twice, we're gonna say derivative of this will be still ex to the exponent x, and then also will remain the same, right? Therefore, how are we going to integrate sine 3x? We're gonna say will be 1 over 3 cos 3x, and then will be negative. This one is negative, this one will be positive, negative also, negative 1 over 9 sine 3x, right? Is how we integrate what sine 3x, right? So now that we have derived e to the exponent x, and we also integrated sine 3x, remember we said we integrated the exponential, we differentiated the exponential twice. Therefore, we're gonna differentiate twice, and then we're gonna integrate the other one to match the column of the derivative, the one that we derived, right? Right now we see that we have meshed. All right. The next step here is to cross multiply on the table we have here. Cross multiply. We're gonna say the first one, cross multiplication, to multiply with the second integration, and then the second one to multiply with the second integration. Therefore, we're gonna straight multiply lastly, and then the last term that we multiply with what we integrated, right? The last term that we multiply the straight, when we multiply straight, we're gonna integrate it on the equation of integrating, right? Let's go and see what am I talking about. Let's see what am I talking about. All right, what am I saying? I'm saying the integral. We're gonna say the integral of y dx is equal to the integral of y dx is equal to, we're gonna add the one that we cross multiplied, right? Which one did we cross multiply? We cross multiply e to the x times negative 1 over 3 cos 3x, right? Therefore, we're gonna add it. We say negative 3 cos 3x plus, right? Plus e to the power negative e to the power x times negative 1 over 9. Negative times negative will be positive, remember? Therefore, multiply e to the exponential to the exponent x times 1 over 9 sine 3x. Let's multiply and write it down. We will be having x over 9 sine 3x plus the last one we are integrating it, right? The last one we are integrating it. Therefore, we get straight multiplication. This one is straight multiplication. We straight multiply. Therefore, positive exponential to the exponent x times negative 1 over 9 sine 3x will have a negative. Negative ex over 9 times sine 3x plus c. Remember, c is a constant, right? C is the constant. We always put it when we're integrating because we are not sure if there was a constant before or there was none, right? Therefore, we're going to keep out, let us put this in order, or it will have something like this will be negative x cos 3x plus ex over 9 sine 3x minus, we're keeping out what? The constant will be minus, and then we're integrating the inside, right? 3x plus c at the end. All right, what are we going? What is our next step? Let's look at the last term there, the one that we're integrating. It is similar to the original one that we have of y, right? The one that we're integrating. They are similar. When they are similar like that, we're gonna do what? We're gonna substitute y by its equivalent, right? Which is ex times sine 3x, right? Is equal to, let's write everything that is equivalent to it, negative ex over 9, let's see, over 3, I made a mistake there, sorry, over 3 plus, sine, for the cos, yeah, it's a cos, yes, cos 3x plus what? X 9 sine 3x minus 1 over 9 integral ex times 3x dx plus c. Therefore, we see that this is identical to this. These are identical. Therefore, since they are identical, therefore we're going to add them, right? Let us take this one to the other side. Let us put it to the other side. We're going to say, let us copy it. X, because it's negative, it will be positive, right? Integral dx is equal to, let's write what is left. What is left? Plus c. Remember, plus c, right? Plus c, right? Therefore, we see that the like terms. Therefore, 1 plus 1 over 9 will be 10 over 9. Will be 10 over 9 ex times sin 3x dx is equal to negative ex over 3 cos 3x plus ex over 9 sin 3x plus c, right? Therefore, this is what we're looking for. This is our u. Remember, we're going to substitute it back to u. Let us do so. Let us substitute it back. Let us substitute it back to u. Alright, let us substitute it back to u. We're going to say 10 over 9 integral of y. Remember, we said we're taking it back to y. Therefore, it will be negative ex 3 cos 3x plus ex over 9 sin 3x plus c, right? Therefore, we're going to divide by 1 over 9 because we're not looking for 10 over 9 integral of y dx, but we're looking for integral of y dx, right? Therefore, we're going to be left with what we're looking for. Will be both sides. We're going to divide both sides. Therefore, our answer when we divide individuals, obviously, when I say individually, divide by 10 over 9 cos 3x cos, right? Plus e 9 over 10 over 9 sin 3x plus c, right? Constant will be a constant. The thing, we don't know what the exact value of the constant, but we'll just say it's a constant, right? We don't know the exact number of it. So here we'll be left with negative 3ex over 10 cos 3x plus here we'll be left with 10ex sine 3x plus c. Now we have come to the answer. Therefore, we have answered what the integral of y dx for number 3. All right. Let us treat number 4. Number 4, right. Example number 4. What do we have? Okay, we are having y is equal to x times cos 3x. Remember, what we're looking for is the integral of dx, x cos 3x, right? Therefore, as we're looking for the integral of x cos 3x, dx, remember, actually I forgot that, dx, we're going to determine what type of integral do we have. We are having what by parts. Why am I saying by parts? Because we have a product of two terms where they're carrying they're carrying a variable that need to be integrated, right? So we're gonna use what Lipet, since it is integration by parts. Lipet, we're gonna draw our nice table here. We're gonna say Lipet here. We're gonna determine which one to derive, which one to integrate. Remember, I said each row should have its sign, right? Each row should have its sign. This one will be positive, this one will be negative, this one will be positive. Yeah. We're gonna determine which one do we have to derive, which one do we have to integrate, right? Alright, let's see, we're having a polynomial. X is a polynomial, right? X is a polynomial, and cos 3x is what? Is a trig. What comes first? Polynomial comes first, right? Therefore, we're going to derive it since it comes first. Alright, it is x, right? And then here we're going to have 3x to integrate, cos 3x, right? Alright, since we're deriving what a polynomial, we're going to derive it until 0. Let's derive it until 0. It will be 1 here when we derive it, therefore here will be 0. Therefore, let's integrate to match what? To fill what the remaining columns, remaining rows, actually, rows. This one and this one, okay? We'll have what? A positive 1 over 3 sin x, 3x, remember? 3x positive 3x and then we're gonna have lastly what negative 1/9 cos 3x, right? All right, now we have matched the color, the rows. Therefore, on our table, therefore going to cross multiply, right? We're gonna cross multiply. Let us cross multiply. Let us cross multiply. Let us cross multiply. Let us cross multiply. All right, when we cross multiply, we're gonna have something like y dx. Remember, when we're cross multiplying, we're adding, right? And then the last term, we're deriving it. We are integrating it. The last term, we are integrating it. Let's see the first one. The first one is x will be x over 3 what sin 3x plus the last one. We're saying we integrate. Therefore negative times negative is positive, therefore it's 1. Therefore it will be 1/9 cos 3x dx plus c plus constant, right? Remember, plus constant. Therefore, gonna say 3 sin. We're gonna keep out what the constant. We're gonna keep out the constant outside the integral sign. Gonna say plus 1/9 integral of cos 3x dx plus c. Therefore, over 3 plus the integral of cos x. Remember, let's refer to the table. Let's see. Yes, let's see. Do you see the integral here? This is what you are looking for. Therefore, the integral of cos x is what? Is sin x, right? But in this case, we're having 3x. Therefore, we're going to derive the inside. We need what? We need 3. We need 3. We need 3 here. Therefore, it will be 1 over times 1/3 into sin 3x plus c. Therefore, our answer will be x over 3 sin 3x plus 1/27 sin 3x plus c. Therefore, this will be our answer. Let me write this down accurately. X, right? X over 3 sin 3x plus 1/27 sin 3x plus c, right? Alright, that is our answer for example number 4. Let's see the last example. Let's see the sorry for that. Let's see our example. Right, example number 5. Number 5, we're having what? Y is equal to e to the power 2x multiplied by sin x, right? Alright, therefore we're looking for y dx x, right? Alright, now this one is also what by parts, because we have product of two terms carrying what variable that we need to integrate, which is x. All right, Therefore, we're going to refer to what? Lipid. Let's draw our nice table. Let us see which one do we have to derive, which one do we have to integrate. Right. Our rows, let's see our rows. Alright. Therefore, every row should have its own sign as a pattern, plus, minus, plus, right? Which one do we have to integrate? Which one do we have to integrate, to derive actually? So the first one that comes on the lipid weight is the one that we derive, right? Exponential is here, and then the trig is here. Therefore, we see that the trig comes after exponential. Therefore, the exponential will be the one we are deriving. And when we are deriving the exponential, we derive it twice, meaning 2 times, right? We derive it 2 times, right? Therefore, let us derive it. When we derive an exponential, remember we derive what? The exponent. We multiply by the derivative of the exponent, which is 2 e to the exponent, right? And then we do the same. We derive the exponent, we multiply, we take it to the front. Therefore, it will be 4e to x, right? Now we have our derivative of exponential to exponent to x, right? Let us match the remaining column. Let us fill the remaining columns by integrating sin x. When integrating sin x, let's go back to our table, our formula sheet. You see that integration of cos x dx is equal to sin x, right? Therefore, the integral of sin x, where my pen is not working, the integral of sin x is negative cos x, right? Therefore, we're gonna see here, what are we having here? We are having, yes, we're integrating sin x. It will be negative cos x. Therefore, it will be, the integral of cos x will be positive, right? Will be sin x. Therefore, we cross multiply. Remember, we cross multiply. Therefore, when we cross multiply, we're gonna write our equation. Alright, our equation y, I'm using a wrong one, but okay, it's equal to, let us cross multiply. We add in them. When we cross multiply, positive e to the power 2x multiplied by negative cos x will be negative e to the power 2x cos x, right? Cos x, right? Therefore, the next one will be negative 2x to exponential to the exponent 2x multiplied by negative sin x, right? We're gonna cross multiply. Negative times negative is what? Is positive, right? Positive, therefore it will be positive 2 x times sin x. Remember the last one, we are integrating it, right? Let us integrate. The last one is the straight multiplication. This applies to when we're integrating exponential, logarithms, and also inverse and exponential, right? Therefore, on polynomial, straight multiplication does not apply, right? So Here's cross multiply. The one that we we straight multiply, we're gonna derive it, then integrate it. I'm sorry. We're gonna integrate it. Therefore, it will be 4 e to the power 2x multiplied by negative, right? Negative what? Negative sin x. Yes, negative sin x. Yes, negative sin x plus c. Remember, constant is very important, right? Therefore, the answer will be, alright, will be, this is not the answer, but we are simply putting things in order. Let's keep out what the constant 4. It is with this sign negative outside. It will be negative 4. That negative x times sine x, ne? Dx plus c, which is constant. Alright, we see that this integral of the last term is identical to the original integral we are solving, right? Therefore, let's substitute y by its equivalent integral, which is integral of e to the power 2x sine x dx, right? Dx is equal to, let's write everything is equivalent to it. Alright, minus 4 integral of what? Of e, right, dx plus constant, right? Plus constant. Alright, let us come here. Sorry about that. We're gonna take this integral to the other side of the equal sign, right? Because they are identical to each other. Therefore, we're gonna say integral of e to the power n times sin x, right? Dx plus, because it's negative on that side, it will become what? Positive sign, right? Dx is equal to negative e. Is it 2? It should be 2 here. Let me see. Maybe I made a mistake somewhere. I missed something. I think I missed it. No, I didn't. It will be, alright, sorry about that. It will be negative e 2x cos, let me see, cos x, right? Yes, cos x plus 2, right? Plus 2 e sine x plus c, right? Therefore, when we add this, will be 5. Let me write it down quickly. Will be 5. Will be 5 sin x dx equal to e x cos cos x plus 2 sin x plus c, right? We're going to divide by 5 since we are looking for derivative. Sorry, let me go back. Right, we're going to divide by 5. Therefore, the answer will be 1 over 5 e to x cos x plus 2 over 5 sin x. I didn't write it well. Let us write this on the other page. Another page. Let me open another page. Okay. As I said, you can write it on the other page. Let's say we said we divide by 5, right? We're dividing by 5, okay, yes. Therefore, we'll be left with e to x times sin x dx is equal to negative 1 over 5 e to x cos, let me see, cos x, yes, cos x plus 2 over 5, plus, yes, 2 over 5 e x cosine, okay, sin x plus c, constant, right? Therefore, let's substitute this back to y because it's equivalent to y. Therefore, our integral of y dx is equal to negative 1 over 5 e to x times cos x plus 2 over 5 e to x sin x plus c. Therefore, this will be our final answer, right? I hope you understand. Therefore, these are our key points that I emphasized more on this lesson. I said always remember to add what constant at the end of the integration, right? You always add it because we don't know if it was there or not there. So, but if it was not there, obviously it will be 0. If it was there, it will be any number, right? We just don't know what the accurate number, right? And then also refer to the formula sheet when integrating to avoid mistakes. I repeat. Okay. Yeah, this is I have a classwork for you. So treat this classwork to understand more of integration by parts together with the U-substitution. This will help you. Thank you very much. I hope to meet you next time, and I hope that you understood. Thank you very much.